well. So I'll just quickly revise you what we have done yesterday in a very quick span, and then we'll move on to the things that I'm talking about today. So let's say I'll just repeat the yesterday's problem first. So we created a regression model. So how will you do that? First of all, you created try to develop a regression model here. So you will you'll go to the quick, and in quick there's an option of estimating equation. You click over here, and then you will start typing your equation like that. So your equation, first of all thing, what is your endogenous variable? That is your dependent variable. So let's say we took for that example, we took small cap returns. It was a curiosity for me to know that whether small caps returns are actually depending on Nifty 50 or mid cap 50 returns or not. So I did that thing. If I want to add a constant in my regression equation, I typed C, and then I'm pressing space. So there's nothing like plus, comma, any sign like that. Only space is being used here. And then you start with R underscore Nifty. So you type it and it will be selected, and we took another exogenous variable that was mid cap 50 returns. So what we are checking here, that small cap 50 returns are depending on the mid cap 50 or Nifty 50 returns. And by default, there are a lot of methods. Will not be covered everything here, but yeah, we'll be discussing about briefly about the arch and other methods. But let us quickly use least square method, which is the most prominent thing. If you want to keep the exact sample size, you can keep it. If you wish to edit the range, you can actually add the range, and you can even provide some if conditions to that as well. So as of now, we are continuing with the entire data that we have, and this is what we got. So this was the regression equation output, and I've already explained on day 6 about the interpretation of majority of the values over here. So the very first important thing, we look at the p-values of individual IVs. That is important. We also look at the probability of the model, p-value of the model, which tells that this is significant. 66% of the variation of dependent variable is explained by the independent variable. That's what we have already discussed and talked. C here represents the intercept, Diksha. So C is the value of intercept. So when you will develop the regression equation, so the regression equation will be read as small cap 50 returns is equal to, this is the A value, this is the minimum return. If the Nifty 50 return or the mid cap 50 return will be 0, then also the small cap 50 will have this much of minimum daily return. So this is the daily return data. So this will be the minimum daily return even if the Nifty 50 or mid cap 50 returns are 0. So that is what you read as intercept. And the equation goes like that. We have already developed the equation. So 0.1060 multiplied by Nifty 50 returns plus 0.915 multiplied by mid cap 50 return. However, we discussed that Nifty 50 returns were not significant predictor here because their p-value is found to be more than 0.05. So they don't carry much weight in predicting the small cap returns because they are far away. The smallest companies are very small and the largest companies are very large. So the whatever is happening in the large cap companies return is not actually translated in the small cap companies return as per this data for this duration. It cannot be generalized because we are having a very small 1-year sample size, and we need to have larger database, and then we want to test it on multiple time frames and frequencies. However, with the given data, we find this is a case, and the KIK information criterion or Schwarz criterion or the HQ criterion, the values will be used when you have more than one model. Let's say I want to now have another model, and I want to check. I'll just do it quickly for you. I want to develop another model, and I just want to see which model is better. So I know that Nifty 50 is not making a sense to be used here. So what I'll do, I'm just creating another equation here, and this time I type R underscore small cap 50. This selects the dependent variable. C is for intercept, and then R underscore. Let me not take Nifty 50 this time because I know that does not take much of the sense. So I'm taking mid cap 50, and I'm trying to see our multi-cap. So which covers majority of capitalization here. So I'm taking multi-cap here, and let me try and run this equation. I'll just run it. So this time you get another set of equation, and again, what do you see this time, that the small cap 50 return is far aligned, more aligned with the multi-cap, But when you're putting multi-cap with mid-cap 50, the mid-cap 50 return, becomes insignificant predictor. So this may happen. And if you notice here, the R square has jumped up because multi-cap has larger representation of the small cap things. So the, R square value has jumped up. And but the important thing is when you try to, create a complex model and you try to see the goodness of it, that's what I explained you yesterday. So the criterions are very important. So we need to keep an eye on the criterion values also. So ideally what we should have done, we should have taken that screenshot somewhere or copied it in some Word file and then copied the same output again in some Word file. And you keep doing that. So if you want to come up with the best model, so the criterion values should be minimum. So these three criterion values, if they are low, so that tells a perfect balance between the complexity of the model as well as the its method of maintaining the goodness of fit as well. So that is the important thing. So we normally keep an eye on these criterion, and the lesser are better. So if these values are lesser, then it is better. And Durville Watson, we discussed that it is a primary indicator of these, observing the autocorrelations between the squared residual terms. Ideally, this value should be 2 because that tells there is no correlation between the squared residual. But if it is less than 2, it tells that the data has something like some positive autocorrelation between the squared residual. So whether it is significant or not, we have already done that analysis here. We could go here and we can run this serial correlation LM test, and then this is the Bush-Godfrey serial autocorrelation, and we could get, okay, the probability value is more than 0.05. So whatever correlation we have is not significant. So that we can measure from here. So this is all we did. One thing that I stopped, the point yesterday on the last session was the normality test. So in normality test, you can actually go to the histogram in normality test. So this will take you to the statistics of the data. It represents the entire data in a histogram, and you can see it looks very close to the normal distribution, a perfect, near perfect bell-shaped curve. And what you can see here, the JAQ beta value is 16.6195951. We won't worry about that value. The probability value is less than 0.05. So here the null hypothesis is being rejected, and that itself signifies you that your data is normally distributed. So there's no problem of no normality over there. So this all you can do. So this is the basic thing. We have discussed about the stationarity, thing also. You can go and click on the heteroscedasticity that we discussed yesterday. So Bush-Perkin, Godfrey test we applied, and it tells you whether your data is suffering from the problem of this heteroscedasticity or not. And here the p-values are less than 0.05. So it tells you that the concept of stationarity is actually missing here. So that homoscedasticity is missing here. So you have to look for some models which talks about the issue of heteroscedasticity. So this is the basic learning that we did yesterday. Now let me say if I wish to change my model, and what I'm doing, I'm in the regression output itself, and I go to the estimate, and I wish to change it to the arch. So on the same set, I want to apply the autoregressive conditional heteroscedasticity. So it will ask you to the basic things like that. I'm not complicating things over here. And even in Gauge, you have lot many options: E-Gauge, P-Gauge, and component arch 1,1,1. So as of now, I'm not going in that detail, but as per the understanding you will develop slowly. Arch is the basic, base of these all models, and Gauge basically goes further, one step further. So in terms of adding more parameters to that heteroscedasticity issue. Rohini, data is showing the homoscedasticity, then we can proceed with the further analysis. We can proceed because least square method, as I discussed on the day 6, that least square method requires data to have homoscedasticity, which is the constant squared residual. So if your data is having the homoscedasticity, you're good to go with even least square method. But in this case, what we found, whatever this model we developed, in this case, we found that this data was suffering from the problem of heteroscedasticity. Then you should not proceed with the further analysis with the help of least square method. because the assumption of the least square method is not being met. So in that case, you should move to the high order regression techniques like arch, gauge, or e-gauge or Parch. So that is the point. So we will proceed with the normal recommendations which are here, and you just click OK. Thank you. Uh, Now what you see here, you need to understand one thing clearly. So one thing is here what you will observe. You have got the mean equation here. This is the mean equation. This is the normal regression equation that we normally get in any regression output. So Arch is providing you another equation that is known as the variance equation. So it is adding some, effect of the variance equation here. So eventually, this model is not a good model that to test with, because what we have done, we have gone with random pickings of the variable without making no theoretical connection with them. But just to make you understand, here what you read from the variance equation. If you see, variance equation is here, and there are two values which are actually being denoted. The first is the squared residual error of leg 1, that is 1 day before. So what it is doing, the variance equation, what it does, it is basically using the squared residual error, squared error of the previous duration. -1 is like leg 1, previous duration, because we are talking about daily data, so it is the squared residual error of previous day. And that value is being used as a variance equation here. So the coefficient of the squared residual error with leg 1 tells us that it is having a minus 0.028045 coefficient. So the value will decrease by when the squared residual error is there. So this will be having a negative coefficient here. So the estimated value will decrease by this increase in the squared residual error by this number. This is the coefficient number. However, is it significant? It is actually not significant. The squared residual error, because in our data, we found that there was no issue of the autocorrelations of the squared error, so that was not creating much problem. So there, this impact is not much significant because it is coming out to be more than 0.05. However, the arch effect or the heteroscedasticity that we want to refer is actually quite significant, and it was significant with the test as well. And you see that here that coefficient goes up to 0.89, which is a pretty high value. And more importantly, here you see that the probability of this value is less than 0.05. So this is playing a very significant impact in measuring the forecast of this particular dependent variable. So when you're talking about measuring the small cap 50 returns, there will be a concern for the this heteroscedasticity effect in the forecasting. So rather than using the least square method, we have to move on with some advanced models here and see how they are coming up with the variance equation. And in variance equation, you are actually getting to know the significance of both the things. Squared residual error, can we use it for the forecasting? So yeah, it is having a certain low coefficient over here, and its p-value is more than 0.05. So it does not make much sense for forecasting, because the previous day's squared residual error is not significantly impacting the dependent variable here. However, the previous day's gauge effect is actually significant here because its p-value is 0.05. It should be taken into the modeling for forecasting the future values of a small cap 50 returns, because this data is suffering from the issue of heteroscedasticity. Because you can understand, Nifty 50 or any broad market index, will eventually have high deviations, and their returns vary. And when they are not constant, it cannot happen that market is behaving constantly on 240 days. So there has to be a variation in the behavior here, and that is what is being captured. And for that, we are using this variance equation. So just to repeat, this I told you in the previous session also, what arch method, by and large is doing here, and all the deviations of the arch, will be helping you in understanding this thing. So they basically check whether the previous days, squared residual error and heteroscedasticity, are they playing a crucial role in forecasting the dependent variable value? So if both the case, let's say if we would have taken a case where both the values would have been, significant. So in that case, you'll be saying, okay, my dependent variable is actually significantly depending on both the squared residual error of the previous day as well as the heteroscedasticity that we are able to see in the values. So that both should be modeled in the forecasting, to get to the proper forecast. If you're not modeling them, if you're not taking use of these errors, because which they are not constant and they are having a significant impact on the dependent variable, so then your forecasting will not be accurate. So variance equation helps you to adjust your forecast depending on these parameters, and that will be giving you a better idea. So this is the concept of autoregressive conditional heteroscedasticity. I'm leaving it to here because I want to cover 3-4 more topics. So this is the base of that thing. So I just repeat, the least square method, will be applied when the data is not suffering from any, correlation issue of the residual errors. Squared residual errors should not have, any autocorrelation. That is what we see. And we also want to ensure that in our data, we must ensure that there's no issue of heteroscedasticity. So if heteroscedasticity is missing, it is good, we could continue with the least square. But if heteroscedasticity is there, then in that case, we have to somehow ensure that we use the appropriate method which takes into consideration that particular part as well. And that's why we move to the arch method here. So this is the explanation of arch. We can further explore the things on various models of arch which are used in advance. So, but this will give you the basic understanding of that issue. Now, let us move on to the next topic, and that is Granger causality test. And what does it mean? So let's say there are two ways of applying Granger causality test. What I'm doing, I have data of returns here, and many returns I have. So what I've done, I've selected all the returns here. So all the returns that I've calculated from my data, they are selected here. And I just go to quick. And because I'm working on a group statistics here, I will click on the Johansson co-integration, this Granger causality test. So I just click here. And you'll see all these variables which I've selected are by default highlighted here. What happened if I don't select these variables over here? If I don't select them, and if I click here, and if I click on the Granger causality, so this box will come out to be empty. The issue will be that you have to type all the returns, on that part. You have to type those returns manually. So I will be required to type everything on the manually. So that will be an edit thing. So normally what we do, we normally select all the returns like this. This is not the value that I want to compare. This I calculated randomly here. I'll tell you how to calculate values in the eViews file, which will be used for the moderation analysis. So you just select all the desired return indices, and then you click on the quick, and you click on the group statistics, and this is the Granger causality. I've seen many papers on Granger causality analysis. So they normally select some stationary time series. Remember that the data series has to be stationary. So before running this analysis, you have to ensure that whatever variables you are putting into the analysis, they are stationary, in nature, because this is one of the assumption and prerequisite of applying the Granger causality. So if your Granger causality test has to be applied, the first thing you'll do, you'll check for the stationarity of the data. That you will apply ADF test or Phillips Perrin or KPSS test, and then you'll be able to apply the Granger causality. Once you have established that your data or the variables that you are studying in this analysis, they are stationary in nature, you can move on with the further analysis of the Granger causality. So I selected all the desired variables, and I just clicked on the quick. Yeah, ADF and PP can be used for measuring the stationarity picture. So we can apply them, and once we get that confirmation that my data is the stationary data, the p-value should be less than 0.05 in ADF test. So when you apply ADF, so you wish to see that value less than 0.05, that will be signifying that your data is stationary. So once you confirm the stationarity, so what you will do in your paper, when you're writing a paper, you will say, okay, this was my first variable, and this was its, ADF statistics, and it was its p-value, and which signifies that data was a stationarity. So you can combine the findings of individual variable to a table, and that you will present in your data as the first analysis part, that okay, I've checked for the stationarity, and these were the ADF test statistics and the p-values, which signifies that all the variables that are taken in the analysis are stationary in nature. Why I'm talking about a stationarity here, reason is very obvious, because Granger causality, what it does, it is basically checking the causing effect. So like any teacher who's teaching in the class, expects that the students will be learning. So he expects that his teaching will, cause some learning. So what is the dependent variable here in this example? The learning. So we wish that learning should happen, driven by the teaching that is being facilitated by the teacher. So any teacher who is entering in the class, he wish that students should learn. So what we say here, that teaching should Granger cause. Clyde Granger was the name of the person who is actually who has used and developed this test, and that's why we call it Granger causality. So Clyde Granger has worked on various statistical techniques like that. So in that case, we say that okay, this teaching is causing some learning. So the Granger is just that name of the person who has proposed this test, So that's why we are using Granger cause. So the teaching is causing learning. So that means learning is dependent on the teaching. So teaching is a independent variable and learning is dependent on it. So here what we are going to do, let me just keep it simple for the first hand for you. I'm just deleting the extra indicators. I've just selected two here. So I'm just selecting two returns over here. CD stands for consumer durables and FMCG is your fast moving consumer goods. So return of the consumer durable segment with the returns of the FMCG segment over last 1 year on the basis of daily log returns. This is what we are trying to analyze. So we wish to see whether if there's a change in consumer durable return, will FMCG returns respond to that? So if there's some change in the consumer durable, does it bring any change to the FMCG returns, and vice versa? If there's some change in the FMCG sector returns, does it bring any change to the consumer durable? So that's what we are trying to measure. So here Y is depending on X, and at the same time X may be depending on Y. So we want to test it both way. Now, what is the application and implication of Granger causality? In regression, you say Y is depending on X. So you cannot, if you wish to have another equation of X and Y, you'll have to develop the regression, altogether differently, and it will be coming up in a different output. So R square value and the F value and every value will come up, but you have to test it differently. What Granger causality does, it uses the same mechanism. However, I'm just telling you the very basic way of running the Granger causality. In one of the paper I was seeing, so they developed an autoregressive term, and then they checked whether without that autoregressive term, the effect of the other variable was significant or not. So they did it in a different way. But anyway, as of now, we are keeping it very simple. So the return of the consumer durable segment, are they affecting FMCG sector returns, or the FMCG sector returns, are they affecting the returns of the consumer durable? Both way we want to check whether Y is leading to X or whether X is leading to Y, or they are both leading to each other or they are not leading to each other. That's what we want to see. And you will wonder why we are doing this analysis. And it is an important analysis. I'm a teacher of finance, so I can give you that insight. We all probably, will be hailing from the domain of commerce, and I guess investment is close to everyone's heart. So when I make portfolio, and if I have selected few securities from consumer durables, and I've selected few securities from FMCG, if you go by the ideal definition of diversification, you wish to diversify in different sectors, not to have, very high correlated, values. So if I'm investing in FMCG and if I'm investing in consumer durable, and both are going hand in hand together, and whenever consumer durable falls, FMCG also falls. Whenever consumer durable goes, and FMCG also goes up, and they are very good friends that way. So is it serving my purpose of diversification? And the answer is probably no. I wish they should not be. Ideally, if they do and my returns are okay, I'll be happy. But the idea of making, portfolio is that you want to diversify, and you want to diversify in sectors which are not much alike. So it's like if I'm putting my money in three different sectors, they should behave, in three different ways. So when one of the sector is going up, if all of them are going up, it sounds okay. But when one of the sector is going down and all other two sectors are also going down, it does not sound okay, because my purpose of making portfolio diversifying is not being achieved here. So that way, I wish to see whether these sectors are actually mutually causing to each other some changes or not. That is what we are trying to measure. So here I just quickly click OK, and this will ask me for the leg. So leg here means at what duration gap you're trying to test it. So by default, if you have a 200 plus annual daily price data, so this takes lag to be 2. But you can moderate this lag on your wish. And there has to be some logical justification. Let's say, if I say there's a change in the consumer durable sector returns today, obviously this change that is occurring today in one sector will be having certain information effect. The news will come in the market, people will assess that information, people will analyze that information, people will react to that information, and efficient market hypothesis will come into the picture. And this might take some time in terms of the reaction. So if one sector returns have gone down in the last day, maybe on the same day it will revert in the consumer durable, maybe it may reflect the impact on the next day, maybe it may be reflecting impact in the span of 2 days. Obviously it will not be having any effect 15 days later. So there's no point taking lag to be 15 here, because what happened 15 days back in one of the sector will not be affecting my sector today. No logic behind that. So we normally test it, ideally the EVs will ask us to test this on the lag 2. But if you think, no, I want to check for the real time impact that is being caused by one sector change to the other sector change, then keep this lag to be 0. If you wish to check it for the today's changes, what changes they are going to bring in the next day's value, then you keep that lag to 1. And here when we are keeping lag to 2, that means we are actually aligning that, okay, one value was changing, how that value is leading to the change in the other sector over the span of 2 days. So this lag definition has to be a logical one. As of now, I'm continuing with the 2 lags here, and you will get an output here. And it's a very simplistic and minimalist, minimal output that you see. So first line here, you read, there's a, the time of the analysis is here, what we are right now. The sample duration is mentioned here, that from what to what duration you have studied this analysis. The legs that you have identified for this model was taken to be 2. You could have specified leg of 1, you could have specified leg of 0, you could have specified leg of 5, 10, 15, but it should make some sense. So I hope that was clear. And then we talked about the null hypothesis here, which are mentioned over here. So the first null hypothesis that you see is FMCG return does not Wenger cause consumer durable returns. In a way, I read it this way, that consumer durable return does not depend upon FMCG sector returns. Or in other way, third way, we can say that if there's some change in FMCG sector return, will it lead to certain Diksha is saying that research papers show the indices data at lag 4 or 6. So the duration of the total duration of the analysis must be, I guess, substantially good. At least 5 years data or 6 years data should be there. Or what is the frequency? Yeah, because it is right, when you have the larger span of the data, maybe you are trying to assess the weak effect. So there's a like 4 or 5 days effect if you want to see that whatever, 5 to 10 years data is there, then probably that makes sense. So it depends again. You have to filter and you have to check whether you wish to use it in which way. And whenever you do one kind of analysis, let me tell you one important thumb rule to follow. So let's say I'm making and writing a paper on causality granular. It is the easiest technique of the EViews. It requires just understanding of stationarity, and you put that data, you run the analysis, your output is ready. You can create some graphs and charts, and you're good to go. You can write this paper in 2 days. If you are good at writing theoretical part of it, the analytical part will be ready in 5 minutes, and copying and pasting will take half an hour. Writing about them, will not take much more than 4 or 5 pages. And then the theoretical building of that paper and your 15, 20 pages paper is ready in a span of 2, 3 days. the easiest paper that we can write in that domain. Now the issue is when we are writing this paper, we need to understand what methodology is going to make sense. So for that purpose, in the same domain, in the same kind of analysis, what leading researchers are following as a practice. So what duration of the amount of the data they have taken, one thing. What was the periodicity of the data? It was daily, weekly, or monthly. And then what lags they were actually using for the analysis. What you can do, even in the single paper, you can come up with the findings because it is not a lengthy finding that you see. You can come up with the lags of 0, 1, 2, and you can compare them. You can create a table. Let's say this table you'll copy paste, in your Excel or Word file. And what you can do, you can actually observation and the hypothesis will not change. The F statistics and probability will change. You can add two more columns on the right of this table, and this is the lag 2. You can add one more two more columns, and you can say these are the values on lag 1 and these are the values on lag 4. So you can compare. Okay, within the panel data analysis, you'll be able to compare that if I'm changing the lags, was it creating any effect on the granular causality? So how much deviation in the values was there? So you can further analyze that particular thing. So which can be done. So granular causality, helps you to determine that part. Now let us quickly understand. I was explaining you there are 3 ways of reading this hypothesis. One, the way it is written, that it does not granular cause consumer durable returns. The simplest way of reading this line is consumer durable returns are not depending on FMCG return. This is the one way. Another way is that FMCG sector returns, if they change, that brings certain changes to the consumer durable returns. So this initial null hypothesis is no, this does not happen. And you see the p-value is more than 0.05, and that tells you that the null hypothesis is accepted. The hypothesis which is mentioned here is accepted, which tells you that FMCG returns are not causing anything to the consumer durable returns. So that way, probability value is more than 0.05. We'll be accepting the null hypothesis there, right? So that is one interpretation. If you wish to check it other way around, like say, if there was some change in the consumer durable returns, was it causing any change to FMCG returns? They say no, the null is no, and the null is accepted here because the p-value is more than 0.05, 0.2243. So eventually what you understand here, that okay, you are able to capture the mutual interdependency of variables. So here, both the variables are not mutually interdependent. So what I see, okay, FMCG sector returns, if they change, they don't bring any change to the consumer durable sector returns. And if the consumer durable sector returns are changing, that is not bringing anything to the FMCG sector returns. As a portfolio maker, as an investor, I would love to have portfolios, investing my securities, in these two segments, because I want to have segments which are not mutually interdependent, because then the idea of making portfolio is actually not valid, because you are making your investment in two sectors which are very sibling kind of sector. They are going in the same path all the time. So then diversification will not come into the picture to your rescue the way you want. So that is one thing. Now let us close it, and the way we were doing it for the all. So let us go and quickly see how the bigger data looks like. So I click on the group statistics, granular causality, and then I click on OK. And next, by default, I'm continuing with 2 right now. And this comes out to be data. So you will see, you can expand this box slightly on the right-hand side to see the entire output that you have. So the most of the cases here, you will find the p-values are actually above 0.05. So this is a huge data use in the sense of, because we selected like quite many variable. So every set of interdependency has been checked. So the first we already have discussed, but here you see, this is important. Healthcare sector does not lead to any change in the consumer durable. So if there's some change in the healthcare, that will not bring any change to consumer durable. In other words, consumer durable returns are not depending on healthcare sector returns, but the healthcare sector returns are actually significantly depending on the consumer durable returns at 5% alpha, because here the p-value is less than 0.05. So if consumer durable sector returns will change, it will bring certain changes on the healthcare sector returns too. So as per the data, it may be said. But again, before saying anything, this is only a 1 year data, so it cannot be a generalized statement. You have to test it and validate it, on various time frame. In one of the papers I was seeing, that gentleman did, the analysis for all the financial years. He took some sectors and then he validated the, causality granger year wise, and then he consolidated that entire report on the total, and then he compared all these year wise derivations with the composite scores. So that was another deep diving into the causality granger. So all that can be done. So, but because as of now, from this 1 year data, we could make out that in this year, the consumer durable sector returns was causing significant changes to healthcare sector returns, because whenever there was a change in the consumer durable sector returns, the healthcare sector returns were also being affected. So healthcare sector return is depending on consumer durable sector returns. There's some theory behind it. We need to see why that happened, or it was only an exception in one fine year. So that we need to check. So this is the basic interpretation of the causality granger. I hope that makes sense. We have discussed by now the autoregressive thing. We have discussed the causality granger. So slowly you can scroll down and you can see whether, okay, approx all the values are having more than 0.05. So nothing, no sector is actually leading to the other sectors, and which is a good sign. Abhaji, yes, this is very much important. What she's saying, I can read out for all of you. That is, the output needs to have some logical sense before concluding the finding. That is important. If it is not there, then there may be issues of acceptance of the paper. Very true. So whenever, see what I said, you just concluded anything on the basis of 1 year data will not be logical. So you have to validate whether this is happening every year or it happened only in this year. And what is the composite, score? Sometimes you can check the granular causality of 5 years slots and then see, how the annual deviations are taking place. So it has to be a logical derivation for sure. It is easy technique. That doesn't mean that you'll just put the return values here and on all the data, you'll be just quickly taking out this table and you write the interpretation and make some charts and it will be presented and accepted. No way. You have to make logical interpretations from the granular causality. One thing you should remember, it requires data to be stationary. In the beginning, you will check for the stationarity of all the variables that you're trying to put in this particular analysis. So, because we are talking about the dependency, and dependency or any kind of forecasting requires both the variables, DVs and IVs, to be independent. That is the prerequisite. Now, one more thing, we have been talking about stationary data a lot. Let me tell you one technique is there which basically filters this issue. And they say that, okay, you have something which is not stationary and still you want to check and see whether they carry certain kind of, integration or not. So if your data is not stationary and it has wider application, let me tell you. So it has wider application, what I'm saying right now. But in general, if you wish to check whether the data in the long run has some kind of relationship between themselves, and your data, variables that you're talking about, they're not stationary by nature. So there's a test for that reason, and that is known as, just a minute. One more query has come from Abaji again, that in some cases, if the data output does not reject the null hypothesis, then would that be acceptable by reviewers? This is a sort of, it's a, what I should say, it's a kind of, scene that we imagine that, okay, every time whenever we are making an hypothesis and we are saying that it leads to certain change in that the other variable, and we wish to reject, the researchers are by default keen to prove that whatever they are doing is actually significant. So they are saying, okay, this leads to, this particular value. And as a researcher, you would be happiest person to validate that thing. Yeah, it happens. So sometimes those kind of, author mindset people, those who become reviewer, they will also be on the same line and they will be saying, you have taken a problem and the problem is actually not coming out to be significant. So by those kind of people, this kind of issue arises. that, okay, every time whenever you're making a research hypothesis, so you have decided either you have to reject it, otherwise your paper is gone. So this happens at times. So eventually, so that is an issue that happens at times. Well, I faced that problem, what you're saying. My I just wanted to explore the mutual interdependency. That was the core purpose. And at various levels, we found that it was actually not uh, accepted. It was not rejected. So the reviewer said that the entire analysis is faulty. So that happens. But if I look at the research perspective of it, my own understanding, my own opinion, and again, research is very subjective and very biased. So what I believe, like, let's say if I'm doing this kind of analysis over here, where I just wanted to see whether the log returns, are actually depending on sector wise or not. And if they're not depending on each other sector wise, as an investor, I'm very happy. I want to identify sectors where the log returns are not depending on each other. They are independent to each other. They're not granular causing to, each other. I'll be happiest person because then I identified those bunch of sectors for my portfolio creation. I'll do the sectoral performance analysis and then put my money into those sectors. But the first thing I want to see whether they are, depending, they're leading to each other or not. So if they're leading to each other all the time, as an portfolio maker or as an investor, I'm concerned. So this might be an implication or the finding of the research that these sectors which are not granger causing each other and they have this set of idea. So this is a good finding for the investors or the portfolio people. So the way you write it then. So what you're asking, I guess it's a valid concern. But again, we cannot make a research always, in a way that we'll be making certain hypotheses and which all are rejected. So what we normally do, the suggestion that I can give you, the short suggestion. So what we normally do, we try to add on few tests into this where we show that, okay, the stationarity test was done and the null hypothesis was rejected and the data was stationary. So you try and highlight that thing again and again. And what I've seen, people have started writing, null hypothesis being accepted in a different way. So now they say we do not have enough statistical evidence to reject null hypothesis. So it's about accepting, but by the use of word rejection. So that is a way of writing things. So whether you're writing that null hypothesis is being accepted, it's a way of denial that, okay, we do not have enough statistical evidence to reject null hypothesis. So eventually people are using these way outs also. So it's a concern, but I guess we have to deal with it and bear with it. Now, if I wish to learn check the long-term relationship or association between the variables in our data set. So what we can do, we can go quickly. Thank you so much, ma'am. So we can go quickly to the group statistics and we can click here on the Johansson co-integration test. Remember, Johansson co-integration test should be applied only to the data series which are non-stationary in nature. So here the idea is that we should be using this test only when the data is non-stationary in nature. So here also we'll check for the stationarity, and after checking the stationarity, we'll see that whether these data series are stationary or not. So I'll show you the basic moderation analysis, and for the thing, again, I'll be dropping my email IDs because few of the questions I could not answer in the FDP session. So we will connect individually. That we can always do. So by fixing some common slots and other things for 15 to 20 minutes, we can connect to each other and understand and work on any issue like that. But I'll be showing you the basic moderation effect. How do we check here? So that I'll definitely cover today only. But if you wish to deep dive into that topic, I'll be happy to connect, via Zoom on one-to-one basis if it is a genuine problem that you're facing. So we can always do that on the free time. We can connect for those things. So as of now, I'll be showing, after this, I'll be showing you the basic moderation effect that we can discuss. So here, what we are doing, first of all, we are going for the Johansson co-integration. What Johansson co-integration does, it basically, captures the relationship, long-term association of the, time series variables, which are non-stationary. So very first thing is obviously you'll be doing the stationarity test and you'll check. I know all the closing indices values of the sectoral indices, are normally non-stationary. So I'll be going with that thing. And if I click here, let me just show you. If I just open it here, I can open the equation here. And when I open the equation, the entire data set is here. And if I click on the unit root test here, combined one, and I just click OK. I muted everyone for a while. So in this case, we can run a combined ADF test, or we could have actually used the probability values for individually. So here you see that ADF test altogether, all group unit root test we have applied, and the group unit root test value is coming out to be very, very high. So it is more than 0.05. So it is not stationary. You could check individually for each thing. So what I did here, I just applied the group unit root test on the untitled, the group that I opened right now. Now, if I wish to run and apply Johansson co-integration test, so I can apply the view co-integration test from here also. Otherwise, I could have used this option here, and I could go to the group statistics and click on the Johansson co-integration. By default, the selected variables will pop up here, and you can run OK here. So this will ask you for certain things. You'll click OK, and this gives you the answer. So here what you will see, what is the p-value. So p-value is less than 0.05. So p-value is less than 0.05. If we say that there's no co-integration at all, there are how many variables? 7 we have taken. So if we say there's no co-integration at all, so that null hypothesis is being rejected. So that null hypothesis is being rejected at 0.05 level. So the critical values and trace statistics is also there. You can compare them as also, but in general, we'll be keeping our reservation to probability value. So that is the way of understanding. Okay, if I say there's no co-integration between the time variables that I've selected, so that is being rejected. So there is significant, co-integration. So these values are obviously they are coming from the same set, so they will be co-integrated. The issue of the co-integration is more severe when you're picking values from capital market, then money market, and then something like some other thing. So like you're picking up some macroeconomic variable. So eventually that may be a concern. So you wish to check the co-integration of the variables which are coming from different, gambit. So then in that case, if your data is not, stationary, you must apply that issue. Quickly, two more things that I want to cover, and then we'll have a quick Q&A round. So one important tool that you can learn here is this vector autoregression. So I'll just quickly click here, and vector autoregression is there. And in vector autoregression, you can select some endogenous variable, that is dependent variable. So let's say if I select some return data over here, so I will have to type it here. So I'll say, let's say I'm talking about FMCG sector returns. I selected one. I want to check for, let's say, IT sector returns. So R underscore IT. I'm checking for R underscore, let's say, I have healthcare. So the sectoral returns only I'm taking here. And by default, I'm selecting lag interval for endogenous variable to be 1 or 2. Data is on the daily parameters. If you wish to add, you can add the lag intervals for your further analysis. So the moment you click here, this kind of output will come. And what vector autoregression does, it offers you the basic parameters. Like if you are saying that this is the dependent variable, R FMCG, it is depending on the lag value, the previous day's return value of the same sector, the 2 days, previous value of the same sector, a lag of 1, in the IT sector returns, lag of 2 in the IT sector return, and similarly for other sector returns. So it offers you the values of the coefficients. It tells you the value of standard errors, and it also gives you the t values. So t values are there, and you need to compare them with the standardized values, table values, to know whether they are significant or not. And at the bottom, you will see the R square value. So which model is more defining? So we are going with a very random thing. So which model is more defining here? So you can see, okay, R square values are coming very poor. So this does not probably make much sense here. So they're not carrying much of the, driving power to each other. So these sectors, as we saw in the granular causality also. So they were not, defining or like leading to some of the issues over here. So that is one thing. So we can say they're not contributing or leading to each other. And you can put down this equation part over here. And the KIK information you can see here. The lesser, the better. Which model has the least value will be considered to be the better value. However, we are considering the FMCG sector returns, IT sector returns, health sector returns, depending on the lag values of their own sectors and the other sectors. And that's what we are sharing here. If you wish to go for the, auto regression in this same, so you can click on the view part here and go to the lag structure. And there you see the granular causality again. Click here. This tells you again that further, summary that FMCG sector returns, even if we talk about leg of 1 and 2 of IT sector and leg in 1 and 2 of healthcare sector, it is, all put together is having a p-value of more than 0.05. So that way it is not significantly depending on that parameter. That's what we could see in the R square values also. So that is the, one kind of interpretation we find. So p-values are more than 0.05. So this dependency is not significant. Last thing for the day, that is moderation term. How do you analyze the moderation term? Let me say that I want to see the moderation of, I just pick anything like, let us put this only. Let's say if I say that FMCG sector and the consumer durable, because they have some kind of return, and I want to say healthcare sector returns are depending on the FMCG sector returns, and I want to check for the moderating effect of the consumer durables over here. FMCG is something which people are buying very often, and durables will be slightly having that frequency to be higher. So healthcare sector returns are depending on the FMCG sector returns, and I want to check for the moderation effect also. So one thing that I need to do, I need to create an interaction term here. So what I'll do, I'll click on the gen. I have to write a command over here that is generate. So I'm typing gen, GENR. And what I want to create here, I want to create an interaction. I want to create an interaction of consumer durable, that is the moderating variable, with FMCG. So I'll create one factor like that, FMCG. And this is going to be equal to what? This is going to be, okay, I'm sorry. Can't see the screen. Is it visible to you, Satish sir? The e-view screen? Yeah, thank you. So I'm typing in the command prompt here. Let me magnify this for you because I'm typing on the very far top end of the screen, and I'll just magnify this for you. So here what we are doing, I'm just creating this code here in the command prompt here. So generate, what interaction term of CD and FMCG. So here the formula for that will be return of consumer durables multiplied by return of FMCG. So what it will do, it will create a new variable in your data set, and that you can hit enter. The moment you hit enter, you'll see that interaction term of consumer durable and FMCG has been created. So for that purpose now, if you wish to run the equation here, we'll go to the quick estimate equation. And in estimate equation, we will be writing what we said, that healthcare sector returns is depending on constant I'm adding here, and it is depending on our consumer durable. And I want to check for the interaction effect of the consumer durable and that thing. So INT, the variable that I've created. So interaction of consumer durable and FMCG. So I just want to check that thing. Sorry, I should take FMCG here because the independent variable is FMCG. Consumer durable was the moderating effect variable. So that I'll do, and I'll just quickly hit on the OK here. So the moment you'll run it, you'll get the output. So the interaction term here is, having the FMCG is having a significant role here. So this is the p-value is less than 0.05, but the interaction term is having a value above 0.05. So the consumer durable is not playing a very significant moderating role here in the explanation of the healthcare sector returns. However, the FMCG sector returns, which is the core independent variable, is significant, and the R square value though is not great. It is only 12%. However, then the model is found to be significant. So we need to find some other factors which defines the returns of the healthcare. But that interaction term of the consumer durable with FMCG is not having any significant bearing here. So this is how you can run the simple, moderation analysis. So I hope that serves the query for now. And definitely, if you wish, we can connect on this, as and when needed. So I'll just drop my email ID to everyone once again. This is the email ID of mine, ankit.saxena@gla.ac.in. I'm more active on this ID. So normally within 48 hours, we get a reply from my end. Before that also you can get. So for any research or academic oriented, learning issue, we can definitely connect. And it's a both way, mutual learning. I've learned a lot during this FDP, let me tell you. One of the query on the eigenvalue also, I'll request you to connect because I've not covered anything on eigenvalue in my analysis. So we can connect on the, personal window, and definitely I'll be discussing on that. So that's it from my side. We are done for the day. And before I just conclude, because then in that case, Diksha, I'll talk to you in that case. My suggestion to you all will be, whatever you have learned in these days, please practice. Please try to develop small papers from it and use this, FDP's learning. Don't hesitate. If you're applying a, small technique for the first time, don't hesitate. You just develop a basic regression model. You just develop, check some stationarity, do something. The first paper you'll write will not be a great paper, but then you'll be able to develop the way of writing, and the more you learn, more you will be able to, explore the world of the analytics. There are so many things. I'm still learning. Reviews is something, I normally say yes to FDPs, but I know only just like 40-50% of it. So there are a lot many things that you can learn. Yes, you were saying something. Thank you for the comments that I'm receiving. Janvi, Dr. Janvi, Bhavna ji, thanks for your, feedback about the FDP. The link has been shared though by the FDP coordinators. So you are requested to fill that feedback form. So other things, faculty development these FDP coordinators will coordinate. So thank you from my side. And
there's one question.
Yeah.
Actually, you mentioned that we can calculate this return in the reviews itself. But usually what we did, we calculate the returns in Excel and then upload the file in reviews and then try to elaborate further testing.
Yes, ma'am. We can use the same command that I have used right now. We can create the, we can go to the proc and we can use that generating term option here. So normally, what happens, because I would have done that thing. Thank you so much, Satish. So that was the basic actually limitation, that limited time of 1 hour a day and covering like two different softwares on that vast scale was my challenge. So thank you so much, Nandini ji. So ma'am, coming back to your query, you can, I would have done that if, in the face-to-face FDPs now, when we visit a particular place, we normally start doing that way only. But because this was an online FDP, and online FDP has certain challenges, me doing things here and you copying those actions, on your system, takes time. So that is a challenge. So for that reason, I did the same thing as you're saying. But if you wish to generate returns in the EViews itself, it can be done. You could use this generate term option here, and the formula you have to apply. So you could apply the log returns formula or the nominal returns formula. Nandini, please connect with me. I'll be definitely putting up that link, with you.
From command prompt, we can generate the formulas and we can get this kind of boxes away. Okay, sir, I'll try. I tried that thing as well, that SPSS file in GEMOV, but it's not possible.
You can connect these screenshots, these whatever problems you are facing, you just take the screenshot, drop to my email IDs, and believe in 48 hours, most probably you'll be getting a response.
Sure. Thank you.
Well, we all are academicians. We understand the pain of academicians nowadays, but definitely for these interactions, I'm always up. Shubhangi, the ideal of small sample size, to reach saturation in the social sciences, normally the thumb rule I've told you in the AMOS part, because social sciences, was more confined to the AMOS analysis. So the questionnaire that you're having. So if you're having a questionnaire of 20 questions, so ideally you should have 200, respondents to run the analysis properly, to ensure the sampling adequacy. But if if you're not able to achieve 200, so at times I've seen references and methodological citations with 8 times of the total questions. So if you have 20 questions, then 160. In one of the paper I read recently, 6 times of the total number of questions. So ideally, you will be requiring 10 times of the questions that you're asking. So if you're asking 15 questions, try to get to the 150. And there are other methods of determining the ideal sample size also. In research methodology, you must have seen that. So that can be applied, but the thumb rule that I normally follow, and I ask my the students, those who are working under me, so we normally refer to that thumb rule of 10 times of the questions that you have in your questionnaire. That will be a decent sample size. Thank you so much, Diksha, for your feedback. Some of you, I could recall your name. So Diksha ji, Janvi ji, and some other participants, Satish ji, and so Abha ji, they were like very constantly active on the chat box, and I tried to be responding to them even during the session. So, and this was wonderful, that much of interaction was really something that I'll take away from this FDP. So thank you so much. I think over to the coordinators.
Thank you, sir, for that enlightening session. I request Dr. Priyanka Ghosh, Faculty, Department of Commerce, UG, to propose a vote of thanks.
No duty is more urgent than giving thanks. We must find time to stop and thank the people who make a difference in our lives. Good afternoon, one and all present here. On behalf of entire Kristu Jayanti College, I deem it my privilege to propose vote of thanks on this last session of FDP. I take this opportunity to extend our heartfelt gratitude to the esteemed speaker of the day, Dr. Ankit Saxena from GLA University, Mathura. Sir, your guiding words on structural equation modeling with AMOS and econometric analysis with e-views was very useful for our teaching fraternity. Thank you so much, sir. I would like to thank our beloved head of the department, Dr. Vijay Kumar R, for his constant help and guidance that radiated a source of energy within us. Thank you, sir. I extend my sincere thanks to the program coordinator, Dr. R.T. Singh, and other faculty coordinators of organizing committee for the successful conduct of FDP. I would be failing in my duty if I did not thank the participant of this FDP who have made this day possible. I also would like to thank each and everyone who has joined here the FDP and making this day a wonderful and memorable one. Thank you all once again. Have a great day. I remain.
Thank you, ma'am. Thus, we have come to the end of the 7 days FDP on structural equation modeling with AMOS and econometric analysis with e-views. I thank all the participants who have joined us on all these days. I request the participants to fill the feedback form. Participants, please note the certificates will be sent to your registered email ID within 7 working days. Once again, thank you so much. Have a great day. Thank you. Thank you, sir.